So hello, I will do this question twice. The first time I will assume in the question that there is a right angle here at D. So let's draw in a right angle. Okay, and if that is 90 degrees, then the triangle BCD, which is an isosceles triangle, okay, if this is 90 degrees, then down here, by definition, these will be 45 degrees. Okay, because 45 plus 45, the base angles in a triangle are 90, and they need to add up to 90, plus this other 90 is 180 degrees. And therefore, if I extend this line here, the angle here will be 180 degrees minus 45 degrees. And that is 135 degrees. So, if this angle is 135 degrees, then again we can use the same idea of the base angle in an isosceles triangles are equal. These are the two base angles of this isosceles triangle. Okay, so we can do 180 degrees minus 135 degrees, and half of that must be one of these angles. Okay, so 180 minus 135 is 45 degrees. Divided by 2 is half of 45. Okay. Now, if this is half of 45, then remember that this is 45 degrees just as this one. Okay. So that means we have here, at this place here, we've got the following situation. We've got 45 divided by 2, that's a smaller angle here, and then this bigger angle is 45 degrees. Let's add these two together. Common denominator, 45 degrees over 2 plus, same denominator, 90 degrees. Okay, add the two fractions together, I get 135 degrees over 2. But if I do 45 over 2 times 3, I get 135 degrees over 2. So I've shown that this angle here is 3 times that angle at C. Let's repeat the procedure now with a much more general and formal write down. So let's say that we don't know this is a 90-degree angle, but we'll call this alpha. Okay, so first thing I will work with this isosceles triangle here. I can say that the angle CBD is congruent to the angle at BCD. These two angles are equal. Right? Okay, then I can say that angle CBD is 180 degrees minus my angle alpha. So I've subtracted this. That will be the sum of these two angles. So I need to divide this by 2. Let's simplify this a little bit. I will divide 180 degrees by 2 to get 90 degrees, and alpha divided by 2 is alpha halves. That's the size of the angle here. I can now calculate the angle over here through the rules for angles on a straight line. Okay, and I can add here, I suppose, isosceles base angles of isosceles triangle. Okay. Right, now I can say that angle CBD plus the angle here, which is CBA, they have to add up to 180 degrees. Okay, therefore angle CBA is 180 degrees minus the angle CBD, which is 180 degrees minus what I've worked out here. That's the angle CBD, so minus, and I have to use brackets here, minus alpha halves. Let's write it without the brackets. I'm multiplying minus 1 out here. 180 degrees minus 90 degrees, and negative 1 times negative alpha halves gives positive alpha halves. Simplify. 180 degrees minus 90 degrees is 90 degrees plus alpha halves. That's the size of this angle, and it makes sense. It's going to be bigger than 90 degrees because it's obtuse. So I'm adding something to 90 degrees here. Okay, let's carry on calculating this angle here. Again, I have an isosceles triangle. If I subtract 180 degrees minus this angle, I get the sum of these two angles here, the two base angles. So I can say that angle CAB plus angle ACB, those are these two base angles here, they are the same as 180 degrees minus that angle, which I've calculated here. Plus alpha halves. I must put that in brackets here. I'm subtracting this angle from 180 degrees. So let's rewrite it. 180 degrees minus 90 degrees minus alpha halves. I've rewritten it without brackets. I will now simplify, and I get 90 degrees minus alpha halves. Okay? So that's the size of these two angles together. Right? If I just want one angle, I need to divide this by 2. So I can write the angle CAB is going to be half of this angle here. Let's multiply out. Half of 90 is 45 degrees. Half of alpha halves is going to be alpha over 4. So that's the angle CAB. This angle here. I've got that angle now. I need to show that this angle times 3 will give this big angle here. That one. So I've already calculated this angle, and I know what this angle is. So let's add these two bits together. The angle BCD is the same as the angle angle BCD is the same as CBD. I've got CBD, that's here. Okay? So the big angle at C, let's write it like this, the big angle at C equals to angle CBD plus that smaller angle ACB. Angle ACB. CBD, I know, it's here. 90 minus alpha halves. 90 degrees minus alpha halves. And ACB, I've just calculated here. It's that really small angle, the same as this one here. These two are equal. So 45 degrees. It's actually minus alpha quarter. So that's what's with me here. Okay, and let's simplify again. 90 plus 45 is 135 degrees. And then minus a half minus 1/4 is minus 3/4. because this is the same. Minus a half can be written as 2 over 4. So minus 2 take away 1, that's negative 3. So we get to negative 3 quarter, negative 3 alpha quarters. So there's an alpha here too. Okay? Right. And now I'm almost done. I just need to show that this angle, the small one here, multiplied by 3, gives me this. So let's check that. Is 3 times 45 degrees minus alpha quarters. If I calculate this, will I get the same as my answer here? Well, 3 times 45 is 135 degrees. And 3 times negative alpha quarter is negative 3 quarters. 3 alpha quarters. So I'm getting exactly the same. And what I needed to show is now done. That this angle is 3 times the small angle CAD here.